Hey there, future coders. Welcome to our channel. My name is Sahil Khan and I'm studying in JNDA College of Engineering. Today we are diving into the world of binary search technique, which is a super speedy searching algorithm that going to save you tons of time. Let's get started. Welcome to our YouTube channel. So our course is divided into 8 easy steps. Those are 1. Introduction to searching algorithms. 2. What is binary search? 3. Pseudocode explanation. 4. Big O notation. And then 5. Real world application. 6. Common mistakes and tips. 7. Recap and recall. And 8. Conclusion. So let's learn about first step, which is introduction to searching algorithms. So you got a huge list of numbers and you need to find one specific number. Do you start from the beginning and go one by one? No, right? So that's what we call a linear search. It's slow like a snail on a lazy day. Instead, we have binary search, a faster, smarter way to find what you're looking for. But first, let's understand the basic idea of searching algorithms. So we have two types of searching algorithms, linear search and binary search. So binary search works on sorted list. That's right, sorted. If your list is unsorted, then the binary search. Now let's learn step number 2, which is what is binary search. So imagine yourself looking for a book in a perfectly organized library. Instead of checking each book one by one, you go straight to the middle shelf and decide if your book is in the first half or the second half. Then you repeat this process with the half that might contain your book. This is exactly how binary search operates. Now let's learn the steps in binary search. Step 1, start with the middle element. So in example here 1 to 10, 6 is the middle element. So if it is the target, you done. Else if target is smaller, search in the left half. Here 1 to 6 is the left half. Or if the target is larger or greater, repeat with the right half. Here 6, 7, 8, 9, 10 are placed in the right half. You search in this right half. Searching for an element in binary search is like playing games when we were younger. Let's break it down with an example. Suppose we have a sorted array list from 1 to 19 as shown here. We need to find the value 7. So what do we do in step 1? So in step 1, start in the middle element, which is 9. So 7 is less than 9. So we look at the left half, which is 1, 3, 5, 7. So in this left list, again we find the middle element, which is 5. So as we know 7 is greater than 5, so we look at the right half of the segment. So we found the value 7. This is how easily we can solve the algorithms. Now proceeding to next step, which is pseudocode. So here we have a pseudocode. So in first line we have a function which is binary search, and in second line we have some variables left, right equals to 0 and len parenthesis arr minus 1. So break it down with some example. So here we have an array list 1 to 5. So left equals to 1 and right equals to 5, and as in the third line we have left is less than or equals to right. In our case, which is true, 1 is less than 5. So mid equals to 3 after doing the operations. And as we proceed to the next line, if arr mid equals to target, let's say target is 4, then mid is not equals to target, which is 2. 3 is not equals to 4, right? So proceeding to sixth line, we return mid. We return the mid value, which is 3. In the seventh line, mid is less than target, which is true in our case. So 3 is less than 4. So if 3 is less than 4, then left equals to mid plus 1 as mentioned in 8 line. So we got the value 4. So hence we found the value 4. On other cases we have ninth line, which is right equals to mid minus 1. So if all these conditions are true, then we return minus 1, which represents an error. Now moving on to the next step, which is big O of notation. Time for some math magic. Let's talk about the efficiency of binary search using big O of notation. Binary search has a time complexity of O of log n. This means that even if we double the size of our array, it only takes a few more steps to find the target. This is super cool, isn't it? Sounds very fascinating, right? Now, moving on to step 5, real world applications. So, binary search isn't just a classroom topic, it used in many real world applications like number 1, databases to quickly retrieve records. Number 2, libraries to find books, both physical and digital, and in games to optimize performance and find game assets. Binary search is everywhere. Now, moving on to step 6, which is common mistakes and tips. Before we wrap up, let's go over some common mistakes. So, number 1 is unsorted list. Remember, binary search only works on sorted list. And number 2, off by one error. So, double check your mid calculations and boundaries. Here is a pro tip. So, write plenty of test cases to catch those sneaky bugs. Now, let's learn step 7, which is recap and recall. Alright, let's recap. So, point number 1 to be recapped is binary search splits the search space in half each time. And point number 2, it's a super efficient with the time complexity of O of log n. And point number 3 is works only on sorted lists. Hooray! Up to now, you have completed 7 utmost steps. Now we are diving into the last step, which is conclusion. And there you have it. Binary search is a powerful tool that makes finding elements in large list super fast. And if you enjoyed this video, don't forget to like, share and subscribe for more coding adventures, and drop a comment below if you have any questions or topics you want us to cover in the next upcoming videos. And have a happy coding, and thanks for watching. I'll see you in the next video. Stay tuned. Bye bye.